What's up guys, this is Masi. Welcome to another video. In this video I want to show you what are the intermediate forms of L'Hopital rule. First example is limit of secant x over 1 plus tan x when x approaches to pi over 2. That's going to be secant of pi over 2 over 1 plus tan pi over 2. Secant of pi over 2 is going to be infinity. Tan pi over 2 is 1 plus infinity, which is infinity over infinity. So we need to use L'Hopital rule. So derivative of secant is going to be secant x times tan x. Derivative of 1 plus tan x, the derivative of 1 is 0. Derivative of tan x is going to be secant squared x, which they cancel out. Is going to be tan x over secant x. That's going to be derivative of the limit of sine x when x approaches pi over 2, and that's going to be equal to 1. Next example, limit of x minus 2x squared over 3x squared plus 5x when x approaches infinity. That's going to be infinity minus infinity divided by infinity plus infinity. So we need to use the L'Hopital rule. The derivative of x is 1. Derivative of negative 2x squared is going to be negative 4x. Derivative of 3x squared is going to be 6x. Derivative of 5x is going to be 5 when x approaches infinity. Then what you can do, these two cancel out, and since they have the same exponent, it's going to be negative 4 over 6, which is going to be negative 2 over 3 is going to be the answer to this question. And next one, limit of x times 1 sine of 1 over x when x is approaching infinity. If I switch x and 1 over h, because here before doing that is going to be infinity times sine 0, which is going to be infinity times 0. That's another intermediate form. So when you change x to 1 over h, is going to be limit of h approaches 0, 1 over h times sine h, which is going to be limit of sine h over h when h is approaching 0. That's going to be equal to 1. That's basically how we do this kind of intermediate forms. Another example is limit of 1 over sine x minus 1 over x when x approaches 0. That's going to be 1 over sine 0 minus 1 over 0, which is going to be infinity minus infinity, which is another intermediate form. So what we need to do, we need to use L'Hopital rule. So we're going to say limit of 1 over sine x minus 1 over x when x approaches 0. What we need to do, we need to have the common denominator, x times sine x, x minus sine x, when x approaches 0. Now as you see here, it's going to be 0 over 0. So we need to use the L'Hopital rule. Derivative of x is 1. Derivative of sine x is cosine x. And here we have x times sine x, which is going to be sine x plus x cosine x. Limit when x approaches 0. That's going to be 1 minus 1 over 0 plus 0. So it's going to be 0 over 0. We need to do L'Hopital rule another time. Derivative of 1 is 0. Derivative of negative cosine is going to be plus sine x. Derivative of sine x is cosine x. Derivative of x sine x is going to be cosine x minus x sine x, which is going to be sine x over 2 cosine x minus x sine x. That's going to be 0 divided by 2 times 1 minus 0, which is going to be 0 over 2, which is going to be 0. So that's the final answer. I hope you enjoyed this video. Please leave me a comment if you have any question. I will leave some related videos and playlists in the description in case you need extra practice question. Please don't forget to subscribe to this channel. You can have access to many other videos regarding calculus, physics, and chemistry. Thank you for watching and have a great day.